Bright Tuty. Every student matters.
Hello dear students, now we will be studying about the image formation through concave mirrors. So let us start up with taking up an activity with the help of an animated video. Let us see what exactly we are trying to do is locating the position and characteristics of an image formed in a concave mirror for different positions of object from the pole of mirror. For this activity, the materials that we will be requiring are, let us see, first of all we will be requiring a table, chalk, then we will be needing a concave mirror, and we will be requiring a lighted candle and a cardboard for using it as a screen. Now let us talk about the procedure, how we are going to perform this activity. First of all, take a concave mirror and find out its approximate focal length, right? Then just with the help of a meter scale, calculate and note down what exactly is the focal length. Now mark a straight line on the laboratory table with the help of the chalk and place the concave mirror mounted on the mirror stand on this line such that the pole of the mirror lies over this line. Now you need to measure the perpendicular distance from the line representing pole, which is equal to the approximate focal length of the concave mirror. Now draw another line parallel to it. This line represents the principal focus of the concave mirror that we have measured. Also measure perpendicular distance from the line representing pole equal to double the approximate focal length of the concave mirror and draw another line parallel to it. Alright. Now this line which we have drawn represents the center of curvature of the concave mirror. Remember that principal focus lies midway between the pole and the center of curvature of a spherical mirror of small aperture. Now we will take a lighted candle and place it about 1 meter away from the line representing center of curvature. Place a cardboard screen in between the concave mirror and the candle and move it backward or forward till a well defined image of the candle is obtained on the screen. Now observe the image of the candle flame carefully and note down the nature, position and relative size of the image with respect to the actual candle image. We will repeat this activity by placing the candle in position number 2 about 10 centimeter away from the center of curvature. Okay. Again we will do the same activity. We will try to take a sharp image. Got it? Fine. Then at position 3, which is on the center of curvature, then again we will move the screen forward and backward in order to try to take a sharp image on the screen. The next position will be position 4 in between the center of curvature, that is C, and the principal focus. Now try to take the image on the screen and note down all the observations. Then place the candle on position number 5, that is on the principal focus. Again try to get a sharp image on the screen and note down the observations. Then at position number 6, that is in between principal focus and pole P. Now you will find that you are not getting any image in case number 6. You got real image on the screen in case of 1 to 5 such that the size of image gradually increases, becomes equal to the size of the candle flame at C and then becomes bigger till F. However, in case of 6, when you have placed the object on focus, you will not get any image on the screen. For that you need to look for the image in the mirror and you will find the image is magnified, virtual and erect. So we will note down all our observations in this table, in which we will first of all write where exactly was the position of object. Then we just noted down the position of the image, then the size of the image and the nature of the image formed. We saw that the various positions of object were at infinity, beyond C, at C, between C and F, at F, between F and P. The position of the image was at the focus F. Second case, it will be between F and C. Third case, it will be at C. Fourth case, it will be beyond C. Fifth, at infinity. And sixth, behind the mirror. As far as the sizes of the images are concerned, highly diminished or point sized image in first case, then diminished, then same size as object, then enlarged, highly enlarged and enlarged. If we talk about the nature of images, in the first 5 cases we saw that the image formed is always real and inverted. But in the last case, we saw that the image was virtual and erect. So these are the various nature, size and positions of images which were formed when we kept the objects at different positions. Hope you have understood with the help of this animated video where exactly on placing the object we will see the position of image formed and what exactly is the size and nature of image formed. We can also study the formation of images by a concave mirror by drawing ray diagrams. Now this is a concave mirror, right? It was painted from the outer bulging part, as we know. This is the principal axis which is going, this is the pole, this is the focus and this is the center of curvature as we know it. Fine. Now we know that if this particular concave mirror is used for making images, the object is always placed in front of it. Now what exactly are the various positions at which we can place the object in front of a concave mirror? So positions of object, just try to relate. If I keep the object over here, fine. So if I have to describe the position, what will I say? That the object is lying in between the pole and the focus. So this becomes my first position and I write it as between P and F, the pole and the focus of the mirror. If I take the object a bit back, then also if I have to describe the position, I will say that it is still lying between P and F. But if I place the object over here at this particular point, now the position changes. Now it is our second position that we are going to write and we will say that the object is placed at the focus. Fine. If I just move this particular object a bit farther, now the position once again changes and it becomes our third position, that the object is lying between F and C. This is the focus, this is the center of curvature and this is the object in between these two. Here also the same position, here also the same position, but if I place the object here, now once again the position is no longer between F and C, but it is at a particular specific point C, that is the center of curvature. If I move it back, then now comes my fifth position, that is beyond center of curvature or behind center of curvature. Now the object can be placed anywhere, anywhere and anywhere, the position will still be beyond C, but to a certain extent. When that particular limit crosses or that extent crosses, then what we say is, we say that the object is at infinity, if the object is very, very far. So first of all, you need to remember these 6 particular positions. Right from the pole, we are placing the object in front of the pole, that is on the left side of the pole, and we are moving the object backwards. Fine. Initially it was between P and F, second position was at F, next it was between F and C, then it was at C, then it was beyond C or infinity. You need to remember these 6 positions. Fine, just close your eyes, just make a concave mirror, just draw principal axis, just mark P and F and C on that, and then try to relate, just visualize these these positions of the object, that the object is placed between P and F, then at F, between F and C, at C, beyond C, and then at infinity. So, these are the 6 positions of objects for which we will be seeing that if the object is placed at these different positions in front of a concave mirror, where exactly and how exactly its image is going to be formed. Fine. Alright. Now, when we will be talking about the formation of image, we have to consider these few things. First of all, we will be looking out for position of image formed, what type of image is forming and where. What type of image when we talk about, then we are talking about the nature of image. And if you remember our previous topics, then nature of image, we always used to consider 2 things among these. One is whether the image is real or virtual. Out of these 2, it has to be one, and either the image will be erect or inverted. Among these 2, the image has to be among one. So, this is the nature of image. Next, we will be also discussing about the size of the image formed. Remember, image was either of same size or it was bigger as compared to the object, that is magnified or enlarged image, or it was diminished or reduced or smaller than the object. So, our purpose is to make the ray diagrams, to find the position of image, to check what is the nature of image, and also to see what will be the size of image. Fine. So, are you ready for the image formations and the ray diagrams for it? Let us take the ray diagrams for that. First, this was a concave mirror, of course painted from the back side, outer bulging part. This is the principal axis going, this is P, this is F, this is C. All these labelings we are aware of. Fine. Now, what I say is, first of all, the object, the first position was between P and F. Now, this is assumingly we are taking an object and we are just naming it AB. This is an extended object which is placed in front of the mirror, concave mirror, at a position between P and F. Now, we know the rules. We have studied 4 rules for image formation in the previous topic, in which we have seen, let us recall, the first rule was, if a ray of light going parallel to the principal axis, after striking a concave mirror, it has to pass from the focus. Second rule, if it is going from the focus, it will become parallel after reflection. Third, if it is going through the pole, then it will be going reflecting along the same angle. And if it is passing from the center of curvature, it has to go straight. Fine, because it is perpendicular or normal. Out of those 4 rules, we can use any 2 particular rules, because for image formation, as we have seen in plane mirror, only 2 rays are sufficient to give us the image. Clear? Let us say, first of all, I will take the first rule, that if a ray of light is going parallel to the principal axis. Now, students, you need to make sure that because these are the ray diagrams and we are showing the ray of light, fine, we have to show the direction of the light rays by marking these arrows. If you are not marking the arrows, you are inviting the examiner to come and deduct your marks. Fine, and I hope nobody likes it in examination, specifically after doing so much of labor. So, put up the arrows. Now, first rule says, if a ray of light is going parallel to the principal axis, after striking it will pass from the focus. So, I will join a ray of light which is going from this focus to this particular direction, showing the arrow. Correct? Second ray of light, I can take any of the rule. I can take whether it is going from the pole, or I can take going from C, anything you want to take. Fine. I am taking it from C right at the moment. If I am taking a ray of light which is going like this direction, which is appearing to pass from center of curvature, after striking it will be reflected back along the same path as we have studied, showing the arrow. Fine. So, these are the two rays, one is parallel to the principal axis after striking going from the focus, another is moving in the direction of center of curvature after reflection reflecting back along the same path. Now, as we can make out from this diagram or this figure that these two reflected rays, they are diverging, they are going away from each other. So, if they are going away from each other, we do not expect these rays of light to meet anywhere or to cross anywhere. So, what we do is we extend these light rays in the backward direction, and when we extend these light rays, then we find a point where these rays of light will appear to meet each other, and at this particular point we will say that the image of the object will be formed or seen. Let us give it a name, A dash and B dash. Fine. So, this is how image is going to be formed and where image is going to be formed when the object is placed between pole and focus, right. Now, if I try to relate the few things that for which I am making this ray diagram, first is position of image. If I am trying to explain the position of image, so what I will say is that the image is formed behind the mirror, on the right hand side of the mirror, and right hand side is known as behind the mirror. So, I will say that the image is formed behind the mirror. This is the position of the image formed. Now, we will be talking about the nature of image. As we see that the light rays after reflecting are not actually meeting, they are just appearing to meet. Therefore, these dotted lines, what do they portray? They are symbolic of the formation of a virtual image. So, this is a virtual image getting formed. Alright, out of the real and virtual option, we say that this is virtual image, because real would have been if the light rays would have actually met. Next, as per the image being erect or inverted, we know that anything above the principal axis is erect, fine, and below the principal axis would have been inverted. So, since the image is getting formed above the principal axis, so we will say that it is an erect image that is getting formed. Got it? Next, as we can see, this was the height of the or the size of the object. As compared to the object, the image is bigger in size, right. So, I will say that the image formed is a magnified image. It is a magnified image. Clear? Fine. So, these are the few things that we can see if the object is placed between P and F. Going for the second one, now the object was placed at focus. You need to remember all those 6 positions for which we are making images. Once again, this was a concave mirror painted from the outer bulging part. This is a principal axis going, this was P, this was F, this was C. Now, where we have placed the object? We have placed the object at the focus. Let us name it A and B. Once again, we will be requiring any 2 ray of lights for showing the image formation. Once again, I will take the first ray of light going parallel to the principal axis. After striking the surface, it will become like this, because it is going to pass from the focus as per our first rule. Got it? Fine. Second, we will take a ray of light which is going from the pole. Now, after striking the pole, it is going to reflect in such a way that it makes the same angle with the principal axis as we have studied earlier. So, we will see that this will be like this. Fine, it is making the same angle. Got it? Now, we can see that these 2 reflected light rays, they are parallel to each other. And if they are parallel to each other, the first thing is they will never meet. And even if they meet, we assume them to meet at infinity. Fine. So, As per the position of image, we will say that the image is formed at infinity, and now the image will be formed on the left hand side, that is in front of the concave mirror, right. As per the other nature and size of the image aspects, the image is a real image. Why real? Real because we are assuming it that the rays are actually meeting each other. Fine. The image formed will be inverted. Why? Because this is the principal axis going continued, and wherever the image will be formed, it will be of course below the principal axis. So, it will be an inverted image, and it will be highly magnified image, highly enlarged image as compared to the size of the object, because this is very well assumed that wherever these rays are going to meet, below the principal axis it will be huge image. Fine. So, these are the various things we observe when the object was placed at focus. This will be the position of image, and these will be the other characteristics, the nature and size of image. Got it? Fine. Let us talk about the third position now. When we have placed the object between F and C. Now, this was our concave mirror. This is a principal axis going. This was the pole, this was the focus, this was the center of curvature. Now, where we are placing the object? We are placing the object, this is the object AB, we are placing it anywhere between F and C. Clear? Once again, two rays we need to take. First ray is going parallel to the principal axis. After striking the surface, it is going to pass from the focus. Clear? The arrows are important. Yet again, I am saying it again and again, the arrows are very important to show the direction. Another ray of light, once again it's in our hands. We can take it either from focus, we can take it from the pole, we can take it from C, anywhere. I am taking it yet another time, taking it from the pole. If it strikes the pole, then it will be reflected, making the same angle as to that of the principal axis, and when we join this ray of light, we will see that this reflected ray meets this our initial reflected ray at this particular point, the point where they are actually meeting. Now, at this point we will say that the image will be formed. We are just giving it a representation of A dash B dash. So, if the object is placed between F and C, this is where we will find the image. Coming back to other aspects, image where it is formed? It is formed in front of the mirror. Where exactly it is supposed to get formed? Beyond C. The image is getting formed beyond C. What type of image is this? The rays are actually meeting each other. That means it is a real image. Then it is formed below the principal axis. So, we say that it is an inverted image. As compared to the size of the object, this is still bigger than it. So, we say that this is a magnified image. So, this is what we observe when the object is placed between F and C. Clear? Taking the next case, that is when the object is moved a bit backward and now the object is placed at C. This was our concave mirror. This is our principal axis going. This was P, this was F, this was C. Again and again, same concave mirror, same P, same F, same C. Sir, getting bored. But of course, you need to understand, you need to relate. Every time you have to practice, because we don't know among these which particular ray diagram you will be getting here in exams. Fine. So, again PFC. Now, the object where it is placed? It is placed at C. Name it. AB. Fine. Now, once again for ray formation, the first ray of light is going parallel to the principal axis. Fine. Now, what exactly this ray will do is, it will go from focus, putting an arrow, right. Another ray of light, it will be going from focus or from pole, anywhere you can do it, and when it will go from the focus, of course you will be doing it with the scale, so in that case you will be able to do it properly. If it is going from the focus, then after striking the surface, it will become parallel to the principal axis. Now, we see that the image is just formed beneath the object. This is the image A dash B dash. It is formed just beneath at C only. So, where exactly is the image formed? The image is formed in front of the mirror and it is formed at C. What are the various characteristics of the image? It is a real image because the light rays are actually meeting. It is an inverted image because the image is formed below the principal axis, and now we will see that it is a same size image getting formed. Got it? So, these are the various characteristics of the image formed when the object is placed at C. Fifth position, now the object is moved further, it will be beyond C. This was our concave mirror. This is our principal axis going, this is P, this is F, this is C. Now, we are placing the object behind C, AB object. First ray of light once again going parallel to the principal axis, after striking it will pass from the focus. Clear? Now, the second ray of light, I can take it from pole or F or C. Just for a change, I will take it from C. If I will take it from C, after striking it will be reflected back along the same path. You can take it from P also, you will find the same result. You can take it from F also, you will find the same result, no change whatsoever. Fine. So, it is not something unique that I am doing, that I am taking specially from C just because there is a particular reason for it. No. Alright. So, we see that these two reflected light rays are actually meeting each other at this particular point, and at this point we will say that the image A dash B dash will be formed. Got it? Where is the image getting formed? It is formed in front of the mirror. It is formed between F and C now. Got it? Next, the image is real. The image is inverted. Real, why? Because we know the light rays are actually meeting after reflection. Inverted, why? Because the image is below the principal axis. And now, we see that the image is a reduced image. It is diminished image as compared to the size of the object. The image formed is basically smaller. Fine. Got it? Our next and last position is when the object is placed at infinity. Right? Now, this was our concave mirror. This is principal axis P, F and C. Now, because the object is placed at infinity, we cannot show the object. We will just show the various light rays which are coming from that particular object. Fine. And we assume that those light rays are coming parallel to the principal axis. Fine. When both the light rays are coming parallel to the principal axis, after reflection they are supposed to pass from the focus, and we see that the image of this object will be formed at focus itself only. So, the image is formed at focus in front of the concave mirror, the image is real because the light rays are actually meeting, and the image is yet inverted image. It will be formed below the principal axis and it will be very diminished image, highly diminished image, highly reduced image as compared to the size of the object, because if we are taking the object to be infinity, then in that case they are huge objects. Fine, it may be star or sun or moon, anything. Fine. So as compared to the size of actual size of star and moons and sun, we will see that the image formed will be highly diminished, highly reduced. So these are the 6 positions where we will find the object being placed in front of a concave mirror, and this is how the image formation will occur. Fine. So let us review once again. In the form of a table, we can make it as to where all of positions we have placed the object, like position of object. Alright. Next we talked about position of image formed. Where is the image getting formed? Then we talked about the nature of image, and last but not the least, the size of image getting formed. Fine. So all the ray diagrams that we have made, let us review them all one by one. My first position where I have kept the object was between P and F. Just for the sake of memory, let us draw a concave mirror. Let us take a principal axis. This was P, F and C. So first position was between P and F. The second position was at F. I hope you have, by this time you have learnt all the positions. The third position was between F and C. The fourth position was at C. The fifth position was beyond C, and the sixth position was at infinity. Right. Now let us recall the position of image, where all the image was getting formed. In the first case, we have seen that the image formed was behind the mirror. Fine. And what was the nature and size of image? The image formed was virtual. The image formed was erect. The image formed was magnified. Got it? At second position, we saw that now the image formed was in front of the mirror and it was at infinity. Now the image was real and the image was inverted, and as per the size, it was highly magnified image. Clear? Next, when it was between F and C, then also the image was formed in front, but now it was between F, it was beyond C. The image was real, the image was inverted, the image was magnified. When we have placed the object at C, we found that the image was formed in front, it was formed at C itself only, the image was real, the image was inverted, and the image was that of same size. Moving further, when the object was placed beyond C, the image was formed in front of the mirror, it was formed between F and C, the image was real, the image was inverted, and it was a diminished image. Fine. When the object was placed at infinity, now also the image formed was in front of the mirror, it was at the focus, the image was real, the image was inverted, and it was highly diminished image. So I hope you all have understood where exactly by placing the object we can see the image is getting formed, what is the nature of the image and what is the size of the image. You need to make all these ray diagrams because in your examination you will be asked with the help of a ray diagram. This will be the question that will be coming. With the help of a ray diagram, show the formation, nature and size of image formed when the object is placed at this particular point in front of a concave mirror. Fine.